Earlier this year, we did several shows about Cloud Foundry, followed by several shows about Kubernetes. Both of these projects allow you to build scalable, multi-node applications, but they serve different types of purposes for different types of users. Cloud Foundry encompasses a large scope of the application experience, larger than Kubernetes. Kubernetes is lower level, and it's actually being used within newer versions of Cloud Foundry to give Cloud Foundry users access to the Kubernetes abstractions. Recording these shows about Kubernetes and Cloud Foundry gave me a wide understanding of how infrastructure is managed across enterprises and how it has evolved. They were really helpful for me, and today's episode gives even more context about Cloud Foundry, how the project got started, how people use it, and where Cloud Foundry is going. Today's guest, Mike Dalessio, is a VP of Engineering on Pivotal Cloud Foundry, and we had a great time talking about his work. Engineering leadership is a fine art, and conversations with engineering leaders are consistently interesting. This was no exception, and I think you're going to enjoy it. Sponsoring today's podcast is Datadog, a cloud-scale monitoring and analytics platform. Datadog integrates with more than 200 technologies, including Cloud Foundry, Kubernetes, Docker, and Kafka, so you can get deep visibility into every layer of your applications and infrastructure, in the cloud, on premises, in containers, or wherever they run. With rich dashboards, machine learning-powered alerts, and distributed request tracing, Datadog helps teams resolve issues quickly and release new features faster. Start monitoring your dynamic cloud infrastructure today with a 14-day trial. Listeners of this podcast will also get a free t-shirt for trying Datadog. Go to softwareengineeringdaily.com/Datadog to get that free t-shirt and that 14-day free trial. That's softwareengineeringdaily.com/Datadog. Mike Dalessio, welcome to Software Engineering Daily.
It's great to be here. Thanks, Jeff.
So you are a VP of Engineering at Pivotal. You work on Cloud Foundry. And I want to start with a little bit of history for how the company evolved. Pivotal's kind of interesting in that it wasn't necessarily a startup that was founded from the ground floor. It was kind of a germination that came out of several different companies coming together and realizing that there was a set of opportunities that wouldn't be best suited with those companies themselves. Could you just give a little bit of history for how the company Pivotal came to be?
Sure. I'll at least give you the version that I know. I started working at Pivotal as a consultant for Pivotal Labs, which is where Pivotal gets its name from. And Pivotal Labs is kind of where the core of how we build software came from. Pivotal Labs has, some very strong opinions on how to build software. It's been called the reference implementation for extreme programming at times. And that actually influences a lot of how the company works today. So that's pretty relevant. In 2012 or so, I think, EMC acquired Pivotal Labs, which is kind of interesting if you think about it, right? EMC is a huge, hardware storage manufacturer. Why would they buy a software consulting firm? Part of that is because we had been working with a subsidiary of EMC called Greenplum, working with them to build, some of the tooling for their data center product. And they were really happy with us. And so EMC kind of bought us and stuck us in a corner for a year and said, don't change anything. We'll figure out what to do. And over the course of that next year, we worked with some of the other companies in the EMC Federation, notably VMware, on the Cloud Foundry project. Worth noting that, given where I am now, a VP of engineering for Cloud Foundry, that it all started as a consulting gig for Pivotal Labs working with VMware on that project. I'm babbling a little bit, fast forwarding to like 2013 or so, all of the CEOs of the various companies, VMware, EMC, Greenplum, Pivotal Labs at the time, decided there was actually a really interesting investment hypothesis here, which is these companies can all combine to build a company that can change how people build software. And this is actually the vision for Pivotal today, is to transform how the world builds software presumably for the better. I like to joke that you might as well assume that we're transforming it to become worse, but we think we're doing it for the better. And so now Pivotal is made up of product teams for Cloud Foundry, which is platform as a service that I think has been covered in a couple of previous podcasts. Greenplum, which is a massively parallel database used for data warehousing. Gemfire, which is this massive in-memory data grid. And Pivotal Labs, which is still where a lot of Pivotal's services are provided to our customers through Pivotal Labs.
The reason I find the story of Pivotal kind of interesting is because the narrative around how companies get built today is typically they start with one specific vertical and then they get extremely good at that vertical and they expand horizontally. And actually this is the case with Amazon, starting with a bookstore, and just you can look back and you can trace back the history. And obviously today Amazon looks like a huge sprawling company, but if you look at each of the areas that they expanded to, in retrospect, it's all systematic and it makes a whole lot of sense. They didn't stray too far from their core competency. It's just that their core competency expanded over time. Pivotal is much different because when it got started, it was from day one, this sprawling array of products that people used. And there were synergies between the products, but there were also a lot of disjoint customers between them. I know you probably weren't in the room when perhaps the CEOs were deciding how this was going to unfold, but how does that affect the management structure and the strategic decisions at the high levels of the company?
It's a great question. We're definitely on a journey together at Pivotal to figure this out. The key bits being, we have these diverse products. How do we make them work well together? I think we've got something that resonates with the market in terms of Spring plus Cloud Foundry. Spring wanting to be the developer framework of choice and have it be tuned to run really well on Cloud Foundry and make Cloud Foundry the best place to run Spring. Incorporating the vision for data products has been a longer journey. Over time, the R&D teams have started to work more closely together. And I think what's happening now is we're starting to express the vision of we want to transform how the world builds software. We want to be the home for everyone's workloads, including your big data workloads. And that's kind of what 2018 looks like for us is really honing that vision and getting all of these products to work together well in a really compelling product.
Mm-hmm. Let's get into talking about Cloud Foundry because that's a topic that I have been asked to cover more often by the listeners. And I want to start with a little bit of the history because this is a project that was started in 2009. It was an open source platform as a service. And in the last almost a decade, it's grown to become quite a popular project. Could you talk a little bit about how it evolved, maybe give a little snippets on the early days of the Cloud Foundry project as well?
Sure. So I wasn't around for a lot of the really early days, but this has been passed down through oral tradition. Originally there were really only two teams working on Cloud Foundry. There was a runtime team that was worried. Their concerns were containerization, container orchestration, the external API calls that need to be made by developers. And then there was the Bosch team, who is concerned with the infrastructure abstraction layer. And what happened over the following, that was in the 2012-ish timeframe. What happened over the following years, though, is kind of a cellular mitosis happened where, so the runtime team split into multiple teams. I think at the time it was there was the routing side, and then there was the container management side of things. And then those teams were empowered to evolve their own pieces of the infrastructure, independently. And over time, we got to the point where we are now, where there's something I want to say 30 or 35 different open source teams working on Cloud Foundry around the world, right? We have teams based in Europe where SAP is working on a Bosch CPI. We've got teams working in San Francisco and pretty much every time zone in between. I can go into a little more specifics about some of those changes if you want.
Maybe you could describe the early customers, the early users of Cloud Foundry, why they moved on to it.
I think the big thing early on, the elevator pitch for Cloud Foundry was, hey, this is like Heroku, except you can run it in your own data center, right? And this is attractive for a certain set of customers who are maybe in a regulated industry and aren't ready to move to the public cloud yet, or maybe they just have their own governance policies around data. Early on, there was massive distrust of the public cloud in banking and insurance, right? They moved late to the public cloud. And so Cloud Foundry was a really attractive option just from the point of view of how do we operate a lot of applications without having to go onto Heroku or other public clouds. And that's why it was attractive initially.
Mm-hmm. Well, let's talk about the deployment of an app to Cloud Foundry. So let's say somebody's getting started with Cloud Foundry. What happens when they deploy their application to Cloud Foundry for the first time?
Great question. So Unzi Fakori, who you interviewed, has this haiku about Cloud Foundry that goes, here's my source code, run it in the cloud for me. I do not care how. And this is essentially what CF Push does. When I run CF Push from my directory, it's going to upload all of my source code to Cloud Foundry, and it goes through what's called a staging process. And staging uses build packs, which are very, very similar in concept to build packs people might know from Heroku. And the job is to turn that source code into a full running application. And that might involve compiling code. If it's a Go application, it's definitely going to involve resolving dependencies. So for Ruby, it's going to run, bundle install. It'll do all of your NPM or pip things if you're in Node or Python languages. And so Cloud Foundry comes with 9 different build packs to support 9 different language ecosystems. And at the end of that, what you have is you have a full-blown running app. All the dependencies are resolved, sitting in a droplet and ready to run on port 8080. And then that blob just gets dumped into a container and spun up. And that's how your application actually runs on the platform and can scale up and down from there.
Perfect. Let's get into the technical details of how Cloud Foundry works. So you've already described how to spin up an instance of an application on Cloud Foundry. Once that is spun up, there are some things like routing and authentication and application lifecycle, messaging, stuff that we should discuss. Let's talk about routing.
Sure.
How is routing configured on Cloud Foundry?
I guess maybe I would start with the cloud controller, which is kind of like it's the brains of Cloud Foundry, right? It's where most of the state in the system is stored, right? It's kind of the canonical single source of truth. And the cloud controller has all the information about what routes should be, up and running for the applications that are up. So the way this generally happens, and to be honest, this is really difficult for me to store all of this state of Cloud Foundry in my head because it's a pretty complicated system by this point, and it's evolving really quickly. But to the best of my abilities, how this works today is when the application is spun up, part of the metadata that goes along with that application is, what route or routes do I want this available under? Like, what are the names? When the application's up and running, Diego, which is the container orchestrator, when it sees that the process is up and running and healthy, right, it will essentially send out a broadcast message to the routers saying, this application's up and running at this IP on this external port. Like, feel free to start sending traffic this way. And so then the frontier of HTTP layer 7 routers is then aware that any incoming requests can be sent to that IP and port. Does that make sense?
Yes, absolutely. And then throughout the different applications that you have running across Cloud Foundry, you might have different levels of authentication. So how does authentication and identity management work within Cloud Foundry?
Oh, that's a great question. So there is an open source component called UAA that's in Cloud Foundry, which can be used as a single sign-on server for anybody who's kind of logging into the system, acting as a developer in the system. If you're an end user who's hitting an application, though, you're not going to use UAA. We have a couple of different ways that we can authenticate the connection all the way to the container. It's really only relatively recently that we've been able to extend encryption and container authentication all the way to the container, right? We used to use the Go router as the SSL terminator, or it was done in front, right? You'd have a load balancer or something in front of the routing tier that would do that. But we do have the ability now this might not actually be in the Pivotal product yet, but this is definitely ongoing in the open source work. We're actually going to be experimenting using Envoy to terminate SSL connections in the container. So we're actually going to be using Envoy as a sidecar process in those containers. Now that I'm saying this, I'm not actually sure when that's going to get delivered. So take that with a grain of salt for now. But that's one way to do this.
Well, it's an exciting development nonetheless.
It is. Another way to do this is to, in the headers, send information about the address that the user is trying to connect to. We can use SNI here to transmit some information through to the container as well. There's a lot of activity in this area. It's pretty interesting.
Yes, definitely. Of course, across any application, you've got storage, you've got databases. How are blobs of data and block storage for databases, how are the different types of storage managed across Cloud Foundry?
Well, there's a couple of different things we can do today. I'll start with maybe the most recent and most interesting bit of this, which is persistent storage for applications. So Diego, for a long time, required that you had a pure cloud-native 12-factor application running, which meant no local storage would be persistent in the container. You should be using a database to do any of your stateful work. But there's a feature in Diego now, spearheaded by a team of people at Dell EMC, to introduce persistent storage to the applications running. And this is done over an NFS binding, right? It's not doing a block storage binding to the application, because we want to make sure that multiple applications can bind to this and write to it, et cetera. So one way to kind of deal with storage, at least on the application layer, if you need it locally, is to use this persistence mechanism in Diego that's available now.
I see.
If you're going to be spinning up databases, though, right? So most of the databases, at least that are part of Pivotal's Cloud Foundry, are going to be BOSH deployed on some level, right? And a lot of these are even going to be on-demand databases that get spun up. So as a developer, if I want a new database, I have the option of connecting to a service broker and saying I would like a database, which will be created in a multi-tenant database. I'll get a slice of that. But you can also spin up an on-demand database, right? So one of the things that Pivotal sells as part of our commercial offering is the ability to spin up a MySQL database, a MySQL cluster, HA, on demand, and use that for my application or set of applications, which is pretty interesting. But in either case, right, this database is going to be deployed on top of BOSH, and BOSH has all of these infrastructure primitives available to deal with block storage. So if you're on Amazon, you'll get EBS, and it'll manage all of your disks for you. It's almost like magic. It's pretty great.
When you're building an application, you need it to be fast, secure, and always evolving. With Kubernetes Engine on Google Cloud Platform, developers can deploy fully managed, containerized apps quickly and easily. Google has been running production workloads in containers for over 15 years. Google builds the best of what they learn into Kubernetes, which is the industry-leading open-source container orchestrator. Kubernetes Engine combines automatic scaling, updates, and reliable self-healing infrastructure with open-source flexibility to cut down development cycles and speed up time to market. To learn more about Kubernetes Engine, visit g.co/getgke. That's g.co/getgke, g.co/getgke. Thanks to Google Cloud for sponsoring Software Engineering Daily. We went over this a little bit in my conversation with Rupa about BOSH, which negotiates this relationship between the Cloud Foundry instance and whatever cloud provider it's running on. So there's this contract that is consistent across any cloud provider that you are on top of that BOSH. Yeah, I guess maybe you could refresh us a little bit on that discussion of the BOSH. I think it's the CPI. Is it the cloud provider interface, the interface between Cloud Foundry and a given cloud provider?
That's right. You have a great memory. Yeah. So the CPI is relatively simple. It's just got a couple of primitives in there. Spin up a VM, spin down a VM, give me a disk, resize a disk, or throw away a disk. So using these primitives, right, you can spin up and run whatever you want on those VMs, though.
Right. And every VM has this Diego cell that manages when an app starts or stops and also manages a VM's container. Can you talk a little bit more about the Diego aspect of things? I think that's relevant for application execution.
Yeah, exactly right. So there are a lot of different kinds of VMs that have to run inside of a Cloud Foundry instance. The bulk of the application work is done with Diego. So there's what we call a Diego cell. And the Diego cell has, a couple of processes running on there to manage the local containers and do health checks and make sure that auctions happen appropriately. But the really interesting bit here is that is where the application containers will end up running. So, and a big deployment, right, there could be a couple of hundred Diego cells, right? We have, one customer in particular I know has just a development environment that has something like 350 Diego cells on it. And we've actually done scaling tests up to 1,200 Diego cells running 250,000 applications. So, wow. Yeah, it's kind of interesting. There's a really great paper about this that you can download from, I think, the open source Cloud Foundry website. With some of those details around it. But the Diego cell itself is where the magic happens.
Cool. So you also touched a little bit earlier on the aspect of service brokers. So service brokers help link applications to services such as databases. Talk a little bit more about service brokers. If I'm a Cloud Foundry developer, what do I need to know about a service broker?
Yeah, the easiest explanation I can think of is that it's simply an abstraction layer for a database or another service. So the primitives in this abstraction are, I would like a database, please. And then it'll come back with like, here's an IP address you can connect to. And then you might say, well, I would like some privileges on this system. And it'll come back with a username and a password for you, right? So the information that it gives back to you is going to be very generic, right? Here's how to connect. Here's what you authenticate with. But the service broker's job is to translate those very general requests into something very specific. So if it's a MySQL database, it's actually behind the scenes gonna create you a new database. It's gonna create a new user. It's gonna set a random password for you and give that back. But this abstraction is general enough that you can use it for things that aren't databases. One of the interesting things about PKS, which is Pivotal's new Kubernetes distribution, is you can actually run these Kubernetes clusters on demand. So I, as a developer, can say, I would like to have a Kubernetes cluster, please. And it'll spin up a cluster and then give me back the information I need to then use kube control to connect and run on that cluster. So that's an interesting idea that you're just spinning up a service. So we use this ambiguous abstract word service to represent. It could be a database, it could be a message bus, it could be a Kubernetes cluster.
When you say that term message bus, when you talk about a message bus running within Cloud Foundry, how do people use messaging systems within? They've got a big, like if I'm a bank, I've got certain messages that I want to publish and have have any consumer that wants to subscribe to that message be able to subscribe to it. So, when you have multiple, when you want to do multicast messaging, that's a common pattern, is the pub sub pattern. You've got a message bus and you've got publishers and subscribers. How do people implement those kinds of systems within deployment of Cloud Foundry?
Great question. So I'll use RabbitMQ as a case that's relatively top of mind for me. Again, I'm going to, as a developer, say, I would like to have a RabbitMQ cluster, please. And there are different plans set up, right? So maybe it's a 3-node cluster, and each of the nodes has, half a gig of memory or something. So I can kind of fine tune what size cluster I want and some of the attributes around that. But then once it's up and running, I will have the permissions to both publish and subscribe to whatever gets put on that message bus. And it's sized appropriately for my application and the number of subscribers and publishers that I have. But behind the scenes, that's actually being deployed by Bosch on demand to new VMs. So it's not running within the Diego application container system. It's actually running on VMs that are spun up on demand.
Could you provide some common use cases for why people would want to use a pub subsystem?
Sure. So the Spring team has a framework called Spring Cloud Data Flow. And the idea here is that you might be running, an Internet of Things, right? You might be pulling, streaming data off of a number of devices. Cloud Foundry supports TCP routing in addition to HTTP routing. So you can have these devices be streaming data in through the Go routers to your applications running. And maybe that all just gets dumped straight into a message bus. And then Spring Cloud Data Flow allows you to set up, essentially a pipeline of functors that will handle this data and process it. And maybe it's, you're subscribing to one namespace, and then you're going to write back to the same cluster on a different namespace and chain all this data together. And Spring Cloud Data Flow has a lot of really great primitives for developers to do that really easily. And that's all built on top of Rabbit.
I've been doing a lot of shows recently about Kubernetes, and one of the things that I've come to understand about that system is the importance of configuration management. And configuration management can mean all kinds of things, like how many instances of a service do you want to be standing up? What are the IP addresses that you want to route different data points to? What kind, you can use configuration for all kinds of things. Is there a global configuration system within Cloud Foundry, or could you just talk about how config management works?
Sure. I think there's a couple of different levels of the system that end up getting expressed through YAML config for the most part. On the infrastructure layer, you're describing essentially the topology of Cloud Foundry is being expressed through a Bash config file. So essentially, I have a config file. It's going to get uploaded to the Bash director, and the Bash director is going to kind of idempotently make sure that the state of the universe matches what's in that config. And that in and of itself is like a really large configuration, because you're describing what are the types and sizes of VMs that I want to use. This is my cloud configuration. There's my actual description of the jobs, the processes I want running on each of these nodes. And then there's also like the set of credentials I have. And all these get kind of merged together because they all have a different rate of change and are stored in different places. That actually all gets merged together by the Bash director, who then makes sure that you have actually paved your architecture your infrastructure the way you need it to be. Then for each application, the application developer can have his own application manifest. And this is going to describe the metadata around the application. So things like, how many instances do I want to have running? What are the routes I want associated with it? How much memory do I need associated with this? How much local disk does the process need? And so that config is under the control of the actual application developer who's deploying to Cloud Foundry. Those are kind of like two examples of where configuration is important. If my application, when it's running, needs configuration, the Spring team has what's called a config server. So I can store my config in a Git repo and set up a hook so that every time I commit a change to that config, the application gets the config pushed to it. And this is really useful, especially when you're trying to do a lot of config as code and iterating rapidly.
Now, Spring is the Java framework that many people use to build their applications, and oftentimes they're using Cloud Foundry as the runtime system for scaling and managing those Spring applications. But if I'm a developer on a day-to-day basis, maybe I'm not interacting with Cloud Foundry so much, except when I'm pushing my code, it's mostly Spring that I'm interacting with. Maybe the Cloud Foundry might be more the purview of the operations person, but that might depend from company to company. In any case, I know that as a developer, I did a lot of work on Spring systems when I was working at various enterprises, and I did find it to be something of a complex beast to understand. I went through, I think, 3 different companies where I worked with Spring without fully really understanding what was going on with Spring. And so when I heard about Spring Boot, I thought this makes a whole lot of sense. It's a simplified, stripped down version of Spring. Can you describe how the Spring Boot project got started?
I'm not sure I can actually do this story justice. I came to the Spring ecosystem relatively late in life. I think I had some of the same experiences that you did, which is like this is just a huge sprawling framework and ecosystem, and like where do you start? And I had kind of like moral objections to writing Java code in XML before Spring Boot came along. I think the short version is probably that Spring Boot was specifically written to address some of those concerns, right? Like, hey, let's write Java in Java. Let's make configuration easy. Let's make things auto-wire. Let's do good things by default. That came out of a lot of what was happening, I think, in non-Java ecosystems at that point. If you look at Rails, for a long time, made its bones by just being like, hey, we're going to do the smart thing by default, but you can configure it however you want, right? And so the Spring team intended Spring Boot to address that. And I think it's been really, really successful. I work with a lot of the Pivotal Labs consultants still who do quite a bit of Java and Spring Boot work these days. And these are people who all used to use Rails, and they were very happy in the Rails ecosystem. And their response to Spring Boot is like, hey, you know what? This is actually pretty good, right? Java makes some things just difficult by its very nature, but like Spring Boot is really easy to use. And when you hear that from people who were steeped in a lot of the, let's call it typeless fun languages like Ruby and Rails, that says a lot. That says a lot about how far Spring has come and how far that ecosystem and community has grown.
When I was just talking a second ago, I realized, although I know that Cloud Foundry is widely used in enterprises, and if you look at a bank or a company that makes canned goods or something like that, these giant enterprises, oftentimes they are running on Cloud Foundry. But I actually have not much of an idea how different teams using the same Cloud Foundry instance? Are they using different Cloud Foundry instances? How are resources shared between them? And I'm sure there are listeners out there that work at large companies that use Cloud Foundry and would love to know more about some common patterns. Can you describe like how a Cloud Foundry, I guess, is it a cluster? Is it shared, or are there different clusters within an organization? How does a giant enterprise like a bank deploy Cloud Foundry and let other people within the enterprise stand up their own applications on top of it, or other instances of Cloud Foundry? I guess, how is it used within large enterprises?
I don't think there's any one way that everyone does this. There are a couple of common patterns, though. One I can think of is there's a really large banking customer has a Cloud Foundry instance. We call it a foundation, although that's probably an overloaded word, but it's a single deployment of Cloud Foundry running for each of their business units. And this means that in all practical reality, they have like 40 or 50 Cloud Foundry deployments that they need to manage worldwide, kind of in a follow the sun model. There are other banking customers that definitely go for we're going to go big on one or two Cloud Foundry deployments, and everyone's going to be multi-tenant on these. They optimize for kind of operational simplicity. Most everybody's running multiple foundations simply for disaster recovery, though. So even if you're going for one big, shared Cloud Foundry instance, you're probably going to have at least two running in two different availability zones, right? These are people who are kind of usually running in their own data center. 80% of Pivotal's customers, at least, are running on top of VMware vSphere, running in their own data centers. And so they'll have two data centers that they'll treat as availability zones. So if one of them goes down, the applications are still running on the other one. And they may even have a third one set up as disaster recovery somewhere else at a very different physical location. And this is going to vary from company to company around what their uptime requirements are, what their mean time to recovery is. So there's a lot of variables here.
Yeah. You mentioned VMware vSphere. VMware is a company I need to do more shows on because it's a company that was in its most prominent days before I got into software. Do you have much of an understanding of kind of the history of how VMware made its way into enterprises and the effect that I guess VMware has on enterprises today?
I don't think I can do the history of it justice, but I can tell you a little bit about where it is today, which is they have hundreds of thousands of installations worldwide in enterprise,
right?
Large and small. Like their penetration in large and medium-sized businesses is just unbelievably high. Their main product, which I called vSphere earlier, but it's really like ESXi is the product, which is it's VM management, right? Like it manages the disks, it manages the network, it manages the VMs for you, it does everything. It's just an incredible piece of software, right? It's providing all of these infrastructure abstractions for like it could be just for like I have a half a rack of machines and I've got ESXi running on it. And this really is a powerful abstraction. Before VMware came along and did this, people were managing physical hardware, right? And the density of what they were being used for was really low, and it was really expensive. And vSphere and ESXi coming along like changed all that in a very fundamental way and made this much, much easier to manage.
Yeah, when you say density, you mean they had these physical servers and you might be utilizing 20% of that server.
Right.
And then VMware allowed you to essentially split that server into a number of servers. And then, this was taken even further with Docker and other containerization technologies that just split up those VMs even further. But it's interesting to look back and just think about the kind of the amount of waste there was. No getting around it back then, but there was just a lot of waste.
Yeah, there's a ton of waste. And in addition, like there were just really long lead times when you needed anything, right? I remember the days when I wanted to like run a demo and you had to put a ticket in with IT and ask for a machine and have this back and forth that would last days where they would say, how do you want your file system structured? And how much memory do you need on this? And, how many NIC cards do you need? And those were really the bad old days, right? It took weeks to get anything done. So VMware having this terrific product that allows companies to just spin up a VM on demand with whatever config you want shortens that time somewhat, right? And then having a platform as a service on top of that where application developers can just be like, I don't really care how much memory or how much disk I have. Just put it on the cloud for me. I don't really care how it happens. Shrinks that feedback loop even more.
I think I talked to Rupa a little bit about, but the Spring Cloud Netflix set of tools. So, I've been reading about the Netflix open source tools for a while. They've got Hystrix, which is a circuit breaker. They've got Eureka, which is a service discovery system. And I always wondered who else works on the Netflix open source stack. What are the other companies that consume this technology? And as I was doing the research for these Cloud Foundry shows, I found that many people who are in the Cloud Foundry ecosystem take advantage of these things. Do you have much knowledge of how that developed?
I have a little bit of knowledge, kind of accidentally. I was pulled in as the facilitator for the Spring Cloud Services inception, right? When that team first came together and said, hey, there's a thing here where we can take all of this Netflix OSS, these building blocks and components, and we can smash it together with some of the other Spring components and create this thing called Spring Cloud Services. I happen to be in the room as a witness to all of that, which was really great. And I think the idea here is similar to like Kubernetes, right? Kubernetes provides all these really great primitives, building blocks for building a platform. The Netflix OSS stuff are really great building blocks, right? But there's high level of complexity to get those to work together to actually accomplish what your goal is. And so Spring Cloud Services was about taking those components, making them easy to use, and being able to reason about them and deploy them on Cloud Foundry with a minimum of fuss.
And something like circuit breaking. So before there was a system, Hystrix, which does circuit breaking and controls interactions between services. And for example, the circuit breaker pattern is if two services are communicating with each other and then there's another service downstream of that, like let's say there's a service A calls service B calls service C calls service D. If service D has some latency and service C is waiting on it, you might get this chain of blocking that happens among these different services. Hystrix is a circuit breaker, which maybe provides a timeout for that last service. So if it's experiencing latency, it times out and prevents this chain of waiting, this cascading failure problem. So prior to something like Hystrix, where people just had writing their own circuit breaker logic randomly in their applications.
That's right. When they remembered to write the circuit breaking logic in their applications, they would do it. I think it's very common once upon a time when people were building microservices for weird behavior to emerge from the system, because like something would be hung and you'd have to wait for like network timeouts to kick in. So then, you'd go through this iterative process of being like, oh, we need to make sure we put a timeout in there. And then you have to add a lot of complexity to the application, like accidental complexity, to make sure that you are handling network timeouts correctly. You're first of all detecting it, and you're then responding to it properly. And Hystrix just makes this just really easy to consume, right? It's like if A, else B. And that just simplifies the whole system of building these complex microservice architectures.
I take it the same goes for load balancing.
Load balancing how? Like load balancing on the front of Cloud Foundry?
Well, in the sense, I guess the client-side load balancer, from Netflix Ribbon. So,
sure,
people writing that client-side load balancing logic in their application code, as opposed to being able to specify it through config in something that they import.
Right, exactly. Yeah, I once worked at a company, we'll go nameless, where there was a team who spent probably 2 or 3 months arguing about the right way to do load balancing. Like, is it random? Is it, are we going to assign certain requests to certain IPs? And at the end of the day, it's really just, it's commodity behavior. You just want to have something that works mostly off the shelf that you can config, and Ribbon does that.
Your enterprise produces lots of data, but you aren't capturing as much as you would like. You aren't storing it in the right place, and you don't have the proper tools to run complex queries against your data. MapR is a converged data platform that runs across any cloud. MapR provides storage, analytics, and machine learning engines. Use the MapR operational database and event streams to capture your data. Use the MapR analytics and machine learning engines to analyze your data in batch or interactively across any cloud, on-premise, or at the edge. MapR's technology is trusted by major industries like Audi, which uses MapR to accelerate deep learning in autonomous driving applications. MapR also powers Aadhaar, the world's largest biometric database, which adds 20 million biometrics per day. To learn more about how MapR can solve problems for your enterprise, go to softwareengineeringdaily.com/MapR to find white papers, videos, and ebooks. MapR can leverage the high volumes of data produced within your company, whether you're an oil company like Anadarko or a major fintech provider like Cabbage, who uses MapR to automate loan risk and has done $3 billion of automated loans to date. Go to softwareengineeringdaily.com/MapR to find out how MapR can help your business take full advantage of its data. Thanks to MapR for being a sponsor of Software Engineering Daily. So what do you think of, since we talked about Envoy a little bit earlier, which is this service proxy that runs in a sidecar next to your application containers, that's a bit of a decoupling of this same kind of stuff like load balancing and circuit breaking, decouples it out of the application code and into a container on its own, as opposed to the Spring model of importing Eureka or importing Hystrix and having it run within your application, although it's partitioned because it's kind of in a library on its own. You have its own config files. Architecturally, is that cleaner to you, or do you think it matters?
I can see it both ways. I think some people are really, really offended by the fact that there's this separate process you've got to communicate with. And the advantage from my perspective, though, is that you don't need to have 17 libraries for 17 languages or frameworks to take advantage of something. A really great example of this, Steel Toe, which is the .NET framework that corresponds to Spring Cloud Services. So think, I'm a .NET C# developer. I want to use all this Netflix OSS. How do I take advantage of it? that ends up being like a relatively thin layer of calls out to the Netflix OSS. And you don't need to actually have this really bulky library to do all these things, because essentially like, hey, there's a thing over there that I'm going to talk to that's got the business logic. It's like a single responsibility principle writ large across your architecture. And for me, I find that much easier to reason about than having to worry about like, is this problem in the network? Is the problem in my library? Is the problem on the server side library? Just being able to reason about like Envoy as an example is like, I'm just going to connect to one place and it's going to figure out, can I, in the service mesh context, it's going to figure out for me, do I have the permissions to talk to that other thing? Where is that other thing? If there's more than one, how is that being load balanced? Like I no longer need to think about any of that. All I'm doing is making one connection to one thing and everything else just happens by magic. That's really lovely. And I think that's much easier to reason about and is worth the additional complexity of having to deal with a separate process.
So to make sure I understood what you said correctly, you're saying that if people in the .NET world, when the Netflix open source set of libraries came out, like Ribbon for load balancing and Hystrix for circuit breaking, you didn't really have access to that if you're in the .NET world, because these are all Java implementations. So you're saying that what people in the .NET world did was spin up a server that ran these Eureka, Ribbon, Hystrix Java services, and then they put some kind of C# shim or API layer between them so that the C# developers didn't have to learn Java. Is that right? They had their own server set up that was running Java?
Yeah, to a first order approximation, right? Like that's exactly what happened, right? Like I'm running Spring Cloud services on my Cloud Foundry instance, but I have a .NET app. My .NET app can use all of these things. It can talk to Eureka. It can do service discovery, just as if it was a Java application. And that's the advantage you get from having these things, separated out from being just a Java library.
Do you see a lot of C# customers running C# on Cloud Foundry?
We do. We have quite a few. Pivotal has quite a few customers that are still in the Windows world, are still running .NET. I think this is it's a largely ignored populace. Like this demographic is completely being ignored by many of the open source projects. I know that Kubernetes, for example, has a SIG Windows. They're working with Microsoft, but I think that that's not quite ready for production use yet. And I'm sure somebody on the internet can correct me about that. But my impression from kind of lurking on some of the lists and in the SIG meetings is that it's not quite ready for production yet. That's a huge missed opportunity, in my opinion, right? There are a lot of really large enterprises who are still running a lot of Windows workloads, right? So this is not, .NET Core can run on Linux, new applications. These are like applications that have been around forever. Big banks probably have tens of thousands of these applications still running, and that prevents them from moving to a lot of the newer platforms, right? So one of the things that I'm proudest of in Cloud Foundry is how far we've pushed our Windows support. Like we can run really large, really like legacy Windows applications in Cloud Foundry, right? We spin up a Windows VM, we run Diego on it, it attaches and talks to the rest of the Diego cluster, that's Linux VMs. And the same CF push experience exists for all of those developers. They can just push their .NET apps and they just run in Cloud Foundry, just like Linux developers have been doing for years. And this is an enormous market opportunity, first of all. And Pivotal is doing great, and our customers are super happy with it. But I think in open source communities, because Windows is perceived as being a difficult operating system to work with, it's expensive to work with, and Microsoft is this big faceless corporation that I don't know how to work with. This is what open source contributors are saying to themselves. It's very easy to just say, well, that problem is too hard, I'm going to ignore it, and I'm just going to focus on the Linux thing because that's fun and it's easy, and I can get mean time to happiness is really low there, right? Mean time to dopamine.
Yeah, and the command line works just like my MacBook.
Right.
How did people in C# world end up on Cloud Foundry? Because I thought there was I haven't done any shows on this, but I thought there was some like .NET server system that was sort of like Cloud Foundry, like a .NET or Windows server thing. I don't really know that ecosystem very well, but what are people choosing between when they're deploying their distributed multi-tenant C# applications? they're choosing between Cloud Foundry and some Microsoft product or not?
There have been and there are cloud products that do support Windows. Apprenda is one. Someone from Apprenda is actually the SIG lead for SIG Windows in the Kubernetes community. CenturyLink had a product many years ago, which is actually what Cloud Foundry's Windows support is based on.
Wow.
Called CenturyLink Fog. And there have been like cloud solutions for Windows applications for a long time. But I think that what I've seen personally from like actually visiting with customers is a lot of people are still just running Windows Server and like manually provisioning these applications onto servers and trying to figure it out at the operator level. And then when that VM or that hardware dies, they have to kind of scramble to figure out, well, let's spin up a new VM. Let's make sure that we've, provisioned the software onto that VM and that it's running well. And it's still, a lot of toil still involved in that for most companies that I've seen.
Fascinating. Every time I do one of these shows about an area that's even slightly unfamiliar to me, it's like uncovering all of this information that I had no idea existed. And there must be thousands of customers that are like that. Like I sometimes wonder what kind of software does an oil refinery run? Like there must be all this domain-specific software that they run that I've never heard of, and it's always interesting going down the rabbit hole, those different areas. I worked at a trading company very briefly, and I did see some Windows applications there because it was sort of like some bank-like systems there, tickers and stock information and so on. But certainly since moving to Silicon Valley, I just do not see any of that. I'm just inundated in the, in the cloud, I guess the cloud native web 2.0 world that is actually like 5% of workloads on the internet.
Yeah, for sure. Interesting story about like oil rigs is we've actually had customers approach us about miniaturizing Cloud Foundry so that they can run it in, a quarter of a rack on an oil rig. And that's actually driven a lot of really interesting innovation. We do have like a small footprint Cloud Foundry distribution that we can use that spins up, I think it's 6 VMs. We can fit in a whole Cloud Foundry into 6 VMs. And that came about from these oil rigs essentially having racks running on them that were essentially like, if that hardware went, then somebody had to get on a boat to bring new hardware out there. And so giving them the same options around VMs moving around between hardware, thanks to like vSphere and vMotion, and having Cloud Foundry running on that. So the apps have a level of HA as well. That's something you even need on an oil rig, it turns out.
Yeah. Pivotal has its own cloud, and I always love to think about the competitive advantages and disadvantages of different cloud providers and how they differentiate from each other. Could you talk about the strategy that Pivotal is architecting for how to build a robust cloud business? And when I say cloud, I mean like hosting, because I think much of the money that Pivotal makes from Cloud Foundry is through like training and support, and I think there is some kind of deal that Cloud Foundry has with customers who are running, even if you're running on AWS or on Azure, you make a deal with Pivotal to help with support and deployments and stuff. But that's different than what Pivotal is developing with their own cloud. So maybe you could talk about the strategic decisions that are being made around building a successful cloud business.
Sure. I'll try. The story of our public cloud product, which we call Pivotal Web Services, or PWS for short, the story there actually starts with really long sales cycles with our customers. So 2 things I can think of. One is just like, hey, how long does it take an enterprise to buy software? Just in general, right? You're talking like 6 to 12 months probably is a good place to start. What that means is it's often a really long feedback loop between us building a feature into the platform and getting feedback from anybody, right? There might be a couple of people who upgrade in a timely fashion, but for the most part, like it was really hard to get feedback on whether we were improving the quality of the product. The second aspect of like enterprise sales is if I'm a developer or I'm running a business unit at a large company, like I want to use Cloud Foundry. Like we signed the contract. I want to start using it immediately, but it's going to take my IT and operations team another 2 months to get around to actually spinning up this cluster because they're waiting on procuring hardware or whatever else. And they want to use Cloud Foundry right now. And so PDubs started as a way to solve both of these problems. Number one, to give our customers an option to run their applications on day one. Like, hey, we have a public cloud. You can just connect in, you can push your applications there. And maybe that's only good enough for staging, given your governance requirements. But it was good enough, and it helped our customers get up and running on day one. But it solved the other problem as well, which is that we became our own customer zero, right? Where we were the first consumers of our own software, and we were running it in production at scale with paying customers, with SLOs. And this is when the quality of Cloud Foundry turned the corner. Even if you asked, other companies involved in the open source product, running Cloud Foundry, bleeding edge Cloud Foundry on PDubs is incredibly valuable, because that is usually our first indication that something is wrong or something is good when we make an architectural change or any other kind of a change. Usually when we cut in feature hits open source, before it's even in Pivotal's on-prem product, PCF, it's going to be up and running on PDubs, usually within a few days. And we immediately get operational feedback from, is this causing CPU spikes? Are there network latencies? Are processes dying? Like, what's going on in the system? And we can analyze it. And we share a lot of this data with the open source teams that are working on these components. It really helped us tighten up our feedback loops, quality hockey sticked at this point. And that upgraded installation process, I think, if you ask most of our customers over the last 2 years, has improved dramatically. And that's all being driven by us running PDubs. Okay. That's kind of the origin story of PDubs. But now it's like, oh, great, we have a lot of paying customers who are running, some of them production workloads in there. How do we want to build our cloud business out of that? I think that's a really interesting question that we're still exploring around how to increase this business, how to describe the value to customers. I think it's still majority enterprise customers who are on PDubs. We're not attracting the startups like Heroku does. Interesting question is, like, does Pivotal want to go there? And I think we're still really pondering where we want to spend our engineering investment at this point.
Well, one place that it does seem like Pivotal has decided to spend some engineering investment is Kubernetes. And I think I'd like to close off the conversation with a short discussion of that. So people who are already on Cloud Foundry, there are some workloads that they may want to deploy to Kubernetes, either now or in the future. How do you see that evolving? How are people going to choose workloads that, how are they going to choose which workloads to run on Cloud Foundry, which to run on Kubernetes? And how do you think Pivotal will position itself to take advantage of the expanse in workload runtimes to Kubernetes as well as Cloud Foundry?
Kubernetes is a really attractive platform for things that are not cloud native applications, right? Just to give listeners a little bit of context, Cloud Foundry does run, if you have an OCI image, a Docker image, you can actually run that on Cloud Foundry, right? We can spin it up, we can run it, we can operate it. It's great. But you're limited within that context of like exactly how your application is going to run. A top of mind example of something that would be just perfect for Kubernetes. We have some large customers who are using a third-party application for some of their own internal monitoring and metrics. And the system is actually its own cluster, right? It wants to spin up 3 instances of itself. It wants to have these things talk directly to each other. I don't know if it uses Raft or whatever, but it's got some kind of a protocol for determining like who's the primary and who are the followers. Cramming that into the Cloud Foundry abstraction is really, really difficult today, right? It's essentially, square peg in a round hole, because, they know that they want exactly 3 of these. And if you have a cloud native app, if you ask for 3, you might get 2, you might get 4, depending on like, are VMs rolling? Did an extra process start up? And it's kind of like, eventually consistent. Eventually you'll have 3, but you might have 2 or 4. And these applications may not be able to discover each other very easily. There's probably an aspect of like writing local state to disk. Like for all of these reasons, it doesn't really fit into the Cloud Foundry abstraction, but it fits really well into like a stateful set on Kubernetes, right? I would like to run 3 of these things. I want to make sure that they can talk to each other, and I can configure all that myself. And we're finding more and more vendors really want to distribute their software through Helm charts or something to get it up and running on Kubernetes. For some extent, right, this is a huge ecosystem play where we want to be working with our partners. They want to be able to provide their software so that it runs on Kubernetes. And we want to be able to run that side by side with all of the Cloud Foundry applications that are probably going to be talking to it. Does that make sense?
It does. This Helm charts stuff, like I've been looking at this recently and talking to some folks who worked on Helm and who, like Brendan Burns, like talking to Brendan Burns about kind of the future of application distribution. And he sort of put this idea in my head that I've kind of talked to some other Kubernetes people about and validated, that people will want to distribute applications through Helm almost like they distribute applications across the AWS App Store, for example. So like, you can find an easy installation for Confluent's version of Kafka on the AWS App Store. But if you wanted to do that on Azure, you would have to go onto the Azure App Store and find a Confluent version of Kafka. And that's because the runtimes of the VMs differ from cloud to cloud, but Kubernetes creates a standardized system where people could install Helm charts, which describe a distributed application. Am I crazy, or does that kind of start to look like an app store? Or is it just a package manager?
You're not crazy. How I am currently thinking about it is that Kubernetes, if it hasn't already, will soon become the predominant abstraction for infrastructure, right? Everyone is going to have hot and cold running Kubernetes on whatever cloud they happen to be on, whether it's Amazon, Google, Azure, or vSphere in their own data center. And to that extent, like things like Helm provide an easy way for people to trade applications, to distribute applications. So it's like a little bit of package management. It's a little bit of like App Store. There's something there.
Yeah.
My personal take on it is that it needs to mature a little bit more, but there's definitely a thing there.
Yeah. Agreed. Okay, well, I think that's a good place to stop. Mike, thanks for coming on the show. It was a wide-ranging, entertaining conversation. I really enjoyed talking to you.
I really enjoyed it too. Thanks for keeping it interesting.
If you are building a product for software engineers or you are hiring software engineers, Software Engineering Daily is accepting sponsorships for 2018. Send me an email, jeff@softwareengineeringdaily.com if you're interested. With 23,000 people listening Monday through Friday and the content being fairly selective for a technical listener, Software Engineering Daily is a great way to reach top engineers. And I know that the listeners of Software Engineering Daily are great engineers because I talk to them all the time. I hear from CTOs, CEOs, directors of engineering who listen to the show regularly. I also hear about many newer, hungry software engineers who are looking to level up quickly and prove themselves. And to find out more about sponsoring the show, you can send me an email or tell your marketing director to send me an email, jeff@softwareengineeringdaily.com. And if you're a listener to the show, thank you so much for supporting it through your audienceship. That is quite enough, but if you're interested in taking your support of the show to the next level, then look at sponsoring the show through your company. So send me an email, jeff@softwareengineeringdaily.com. Thank you.
Wow.